Okay, this is the September 2021 or November 2020 paper 2 chemistry question. This is the organic chemistry question, the one that uses the organic chemistry reactions, question 4. It says the flow diagram below shows various organic reactions using propane as the starting reactant. R, T, and U represent different organic compounds. So here's R, T, and U. Compound T is a carboxylic acid, and compound U is a functional isomer of pentanoic acid. So pentanoic acid, carboxylic acid, what are carboxylic acids functional isomers with? They are functional isomers with esters. So then chances are that if we've got something that we are adding a carboxylic acid to, we are going to form an ester over here, because a carboxylic acid plus an alcohol gives you an ester and water. Okay, it says write down the name and type of reaction represented by reaction 1. So what have we got here? We've got an alkane and we are adding a halogen. What are we going to end up with? We are going to end up with a haloalkane. What kind of a reaction is this? This is a substitution reaction, because why? An alkane is fully saturated, and all we are doing is swapping one of the hydrogens out for a bromine atom. So you could say it's substitution. You can also say it is halogenation, because we are adding a halogen atom, or swapping out a halogen atom more accurately. Or you can be even more specific and say it is bromination, because it is specifically a bromine atom that we are swapping out for the hydrogen. Then it says reaction 2, we have a haloalkane, we add dilute sodium hydroxide, and we end up with propan 1-ol, which is an alcohol. So what is this again? We have taken the bromine atom off and we have put a hydroxyl group in its place. This is also a form of substitution, okay, when we take the halogen off, but it has another name. It is also called hydrolysis, okay? But the substitution is easier. We had a saturated compound to another saturated compound, so we just swapped the bromine off for a hydroxyl group. It is substitution. Now it says, consider reaction 1 and reaction 2 and write down the IUPAC name of compound R. So what is compound R over here? It's this haloalkane. Why are they telling you to look at reaction 1 and reaction 2? Well, what has happened here is we have got propan 1-ol here, okay? So what is the 1-ol telling us? It's telling us that the hydroxyl group is on carbon number 1, okay? So what does the hydroxyl group swap with? Does it swap with any random hydrogen on the haloalkane, or does it swap with the bromine? It swaps with the bromine, okay? So the IUPAC name of compound R has to be 1-bromopropane. We know it's bromopropane because we added bromine to propane, so we need the propane because we've got 3 carbons. We know we added bromine, but which atom is it on? It is on the first carbon atom, because that's where the alcohol replaced it, so it is 1-bromopropane. It is not dibromopropane, because if it was dibromopropane, then either we would have a diol on the end here, it would be propane 1,2-diol, something like that, or it would be bromopropanol, because there's another bromine atom somewhere. But that's only showing you there's one hydroxyl group here. It is on carbon 1, and that is what has been swapped with the bromine. So this R has to be 1-bromopropane. Now it says to you, reaction 3, which is the alcohol plus the carboxylic acid going to the ester. Reaction 3 takes place in the presence of a catalyst and heat. Write down the name or formula of the catalyst. Well, the catalyst is sulfuric acid. Goodness, my handwriting gets better every day. H2SO4 concentrated, also called sulfuric acid. And it has to be concentrated to help with its dehydrating properties. Okay, so it's the catalyst. What is the IUPAC name of compound T? So compound T is a carboxylic acid. Okay, so how do we figure out which carboxylic acid we've got? They said to you that compound U is a functional isomer of pentanoic acid. So this pent prefix means 5. Okay, so we've got 5 carbons in this ester. It is a 5 carbon ester. Prop is 3. Okay, so what is the difference between the product? We went from a 3 carbon to a 5 carbon. We have to have been adding a 2 carbon carboxylic acid. And what is the prefix for 2 carbons? It is eth. So 4.1.5 is going to be ethanoic acid, also known as acetic acid or vinegar. But what is the IUPAC name? The IUPAC name is ethanoic acid. Then it says, what is the structural formula of compound U? So we know that we're going to have to make an ester. So what does the ester thing look like? It is a carbon with a double bond to an oxygen, and on the other side there is a carbon. This is like the functional group of an ester. But what is the most important thing to look at here? We know that we've got a 3 carbon alcohol and a 2 carbon carboxylic acid. So we must check we end up with 5 carbons in all. So there are 2 carbons. Can you see this half that I've just drawn over here is the half from the acid? Okay, so then on this side I need 3 carbons for the alcohol. So check 1, 2, 3, 4, 5 carbons, and I have the functional group for the ester over here. So then I just need to check that every carbon now has 4 bonds. Okay, this one that's in the ester link here has already got 4 bonds. The oxygen has 2 bonds. Every oxygen must have 2 bonds, which equates to 2 little sticks. So this carbon's got 4 bonds, this oxygen's got 2 bonds, this oxygen's got 2. This carbon only has 2 at the moment, so I'm going to add 2 hydrogens. This one's got another hydrogen. And here on the end, the last carbon has only got 1 stick. So we have to then go and put 3 on the end there. So there we go. There is my structural formula of compound U, which is, propyl ethanoate. Okay, and then we come to the last part of the question, which says a laboratory technician wants to prepare but2-ene using but1-ene as a starting reagent as shown below. And the following chemicals are available in the laboratory: concentrated sulfuric acid, water, and concentrated sodium hydroxide. Select the chemicals required to design this preparation from the list above. For each step of the preparation, write down the balanced equation using structural formula for all organic compounds. Indicate the chemicals needed in each step. So before you tackle this, you should probably have a piece of paper to help you think what's going on. You need to really know all of your organic chemistry reactions really well before you can do this, the general reactions. So what have we got here? We've got an alkene, and we want to make another alkene. Okay, so we know we make alkenes by elimination of some other saturated compound. Okay, and what are we trying to do? We're trying to move this double bond. So we have to have something that can undergo an elimination reaction to form but2-ene. And in the reactions that we normally have to learn, you can eliminate from an alkane, okay, and you can eliminate from an alcohol. And then possibly sometimes you can do interesting things with a haloalkane. But can you see in these reactions, can you see anything that looks like a halogen? There are no halogens here, okay? So we're going to have to do something. We also sometimes can go from an alkene to an alkane back to an alkene by adding hydrogen gas. Do you see hydrogen gas here? There is no hydrogen gas here. This sulfate ion is doing nothing in organic chemistry. it sits and it's just lurking there. It exists, but it's not going to do anything interesting. So what kind of atoms are we left with? Sodium atoms, OH atoms, OH atoms, H atoms. So the sodium atoms are not going to bond to anything interesting in an organic compound because they just don't do that, just like the sulfate atoms. So we are left with oxygen and hydrogen atoms. And what do oxygen and hydrogen atoms tend to make? They tend to make a hydroxyl group or an alcohol. Now, when we make alcohols and haloalkanes, there's often talk about this is the minor product and this is the major product, and you often have to figure out using Zaitev and Markovnikov's rule where things are going. And it involves either the alcohol or the halogen. So this actually makes sense that if we're going to make an alcohol, we can then put the hydroxyl group on a different atom, and then if we then remove the hydroxyl group in a second reaction, okay, we will then end up with a different shape of alkene. So what we in short want to do is we want to take an alkene to an alcohol and then turn the alcohol by elimination back into an alkene, but an alkene with a different shape, okay? So you have to know all of these reaction conditions. How do you get the alkene to the alcohol? How do you get the alcohol back to the alkene? So what you would do is we're going to start for step 1, okay? What are the reaction conditions for this? You want to add water in the presence of sulfuric acid, okay? In the presence of the concentrated H2SO4. That sodium hydroxide is not doing anything useful here. It's just sitting there to check if you actually know your reaction conditions. So let's draw what we started with in step 1. Here's my 4 carbon but1ene, okay, because it says structural formula. So these ones with all the little sticks are the structural formula. This carbon's got 3 bonds, this carbon's got 2 bonds. So here is my but1ene, okay? It says structural formula for the organic compounds, so we can just write H2O over here because H2O is not a carbon-hydrogen thing. So what will happen now is the hydroxyl group from the water in the presence of the H2SO4, which we will write on the equation arrow. So let's just make my equation arrow a bit bigger. Any reaction conditions go on the reaction arrow, okay? So we added the sulfuric acid, and now what's going to happen is we're not doing anything to our carbons. We've still got our 4 carbons, but that double bond has been attacked, and we are going to put a hydroxyl group on the second carbon due to that guy's rule, okay? And then the rest of the molecule, everybody's got 4 bonds, which we fill up with the hydrogens, okay? So here we go. We've formed this alcohol, okay? And then what's going to happen is that we are going to take this alcohol. This is step 1. And then let me change my pen to the other color so you can see it more easily. Here is step 2. We are going to take the alcohol and do an elimination to an alkene. So we need to add the sulfuric acid and we need to heat it, okay? So now what you have to do is for step 2, you have to redraw this whole alcohol structure because it says for each step draw the organic things, okay? So here is my, what is this, butan-2-ol, okay, because there's 1 hydroxyl group on the second carbon. So here's my butan-2-ol, and we are adding sulfuric acid, concentrated, and heat. You can also draw the little triangle on here. It's another way of showing heat. And then we're going to end up with an alkene, which is but2ene, okay? So but2ene on the second carbon is the double bond. Be sure to draw only 4 carbons and then start counting your sticks. Okay, that's got 4, this has got 3, we need to put another hydrogen, this has got 3, we need to put another hydrogen, and this one now has 4 hydrogens attached to it. Okay, so this is now but2ene, but remember what happened when we did this. We actually have removed something from here. We removed the hydroxyl group and a hydrogen, so one of our products on the right hand side is in fact also water. So effectively what we did is we added water and then we removed water, and that's how come the chemical formula of the starting thing and the final thing is exactly the same. All we did was we moved the double bond by the addition of a hydroxyl group.